Most beekeepers feed protein patties in late winter. Most see minimal response. But in 1938, commercial operations across the upper Midwest documented brood expansion beginning 7 to 10 days earlier than control hives, not by changing what they fed, but by changing where they placed it. The difference wasn't nutrition, it was positioning. The standard method places pollen substitute on top bars, above the cluster but below the inner cover. Bees access it, they consume it, but buildup remains slow. The repositioned method placed the same patty directly above the brood nest center, separated only by a single thickness of cloth. Brood area doubled within 14 days compared to late winter baselines. The question isn't whether protein stimulates egg laying. The question is why placement determines response speed. Have you fed pollen patties and seen little change in brood expansion timing? Between 1936 and 1942, experimental beekeeping stations in Wisconsin and Minnesota tested feed positioning as a variable separate from feed composition. They were attempting to solve a persistent commercial problem: unreliable spring buildup despite adequate stored pollen and supplemental feeding. Standard practice positioned patties horizontally across top bars. Bees moved upward to feed, but brood expansion lagged behind temperature increases. The working hypothesis was insufficient protein quantity. Trial data suggested otherwise. Identical patties, different placement, measurably different brood curve timing. The core issue wasn't starvation, it was efficiency. A colony in late February or early March maintains a tight cluster. The queen is restricted to the warmest center. Nurse bees remain close to developing brood. Foragers are inactive. The entire metabolic system is designed to conserve heat and minimize movement. When protein is placed 12 inches above the cluster edge, nurse bees must leave the brood nest, move upward, consume pollen substitute, and return. Each trip costs thermal energy. The queen doesn't move. The brood nest doesn't expand until nurse bee population and temperature stabilize. But if protein is positioned directly above the cluster core, nurse bees access it without leaving the thermal envelope. The method is deceptively simple, but simplicity required precise observation of 3 biological factors. First, the queen's position within the winter cluster is not random. She remains at the geometric center of the warmest zone, which migrates slowly upward as outside temperatures rise. Second, nurse bees feeding developing larvae do not range widely. They operate within a 6 to 8 inch radius of active brood. Third, upward heat movement in a top bar hive creates a narrow thermal column. Protein placed within that column is accessible without cold exposure. The 1938 trials didn't invent pollen feeding. They repositioned it to align with cluster behavior. Understanding why this works requires understanding how nurse bees process protein and how brood expansion is regulated. A queen doesn't simply lay eggs at random. Egg-laying rate is controlled by pheromone feedback from nurse bees, available comb temperature, and protein availability within the nursing population. All 3 factors must align. When protein is distant, nurse bees make fewer feeding trips. Larval development slows. The queen receives delayed pheromone signals indicating limited nursing capacity. She reduces laying rate. When protein is adjacent, nursing efficiency increases. Larvae receive consistent feeding. The queen receives accelerated readiness signals. Nurse bees metabolize pollen into brood food within hypopharyngeal glands. This process requires approximately 48 to 72 hours from pollen consumption to active jelly secretion. In a dispersed feeding model where bees travel to a patty 12 inches away, consumption is intermittent. Nursing bees leave the brood area, consume protein and return. But cold exposure during travel increases metabolic cost and reduces gland efficiency. In a proximity feeding model where protein is positioned within the thermal column, nurse bees access nutrition without thermal loss. Gland production stabilizes earlier. Brood food availability increases sooner. This is not theoretical. Dissection studies from the 1940s confirmed higher hypopharyngeal gland development in colonies with protein positioned above cluster centers compared to colonies with protein at hive edges. A queen's egg-laying rate responds to nurse bee pheromone signals. Specifically, young nurse bees produce brood pheromone, indicating readiness to care for larvae. When brood pheromone concentration increases, the queen increases laying, but brood pheromone is produced by bees actively engaged in larval care. If nurse bees spend time traveling to distant protein sources, they spend less time attending larvae. Pheromone concentration plateaus. The queen's laying remains suppressed. Proximity feeding keeps nurse bees in contact with brood. Pheromone signaling intensifies sooner. The queen responds by expanding her laying pattern into available warm comb. This is why doubling brood is not literal overnight doubling. It's a 10 to 14-day advancement in brood expansion compared to a typical late winter baseline. If this biological explanation is making sense, a like helps this reach more beekeepers working through buildup challenges. The historical method specified precise placement. Step 1. In late February or early March, when daytime temperatures first reach 50 degrees Fahrenheit consistently, inspect the top of the winter cluster. Do not break the cluster apart. Simply lift the inner cover and note where the cluster mass is visible between top bars. Step 2. Prepare a standard pollen patty, approximately 1 pound, formulated from pollen substitute, sugar syrup, and dry pollen, if available. The specific recipe matters less than positioning. Step 3. Place a single layer of cotton cloth, muslin or old t-shirt material, directly on top of the frames where the cluster center is visible. The cloth prevents bees from propolising the patty to the frames, but allows scent transmission and heat passage. Step 4. Position the patty flat on the cloth, centered over the cluster. Do not offset it toward hive edges. Do not place it near outer frames. This method depends on thermal timing. If applied too early, the cluster is too tight and bees won't access the patty. If applied too late, natural pollen flow begins and the intervention is unnecessary. The ideal window is when daytime highs reach 50 to 55 degrees, but nighttime lows still drop below 40. This is when the cluster begins loosening, but hasn't yet expanded broadly. In northern climates, this occurs in late February to mid-March. In southern climates, it may occur in January. The calendar date is less important than the temperature pattern. Monitor cluster position every 4 to 5 days. If the cluster has moved upward into the patty, replace it with a fresh one positioned slightly higher. Bees should always have access to protein within 4 inches of the cluster top. Mistake 1. Placing the patty on outer frames instead of cluster center. Bees may eventually reach it, but thermal efficiency is lost. The entire advantage of proximity feeding disappears. Mistake 2. Using an impermeable barrier instead of cloth. Bees rely on scent to locate food. Plastic or wax paper blocks volatile compounds. Use breathable fabric. Mistake 3. Feeding too early when the cluster is rock hard. Bees won't break cluster to access food above them until internal temperature allows movement. Wait for loosening signs. Visible bees between frames on warm afternoons. Mistake 4. Assuming more protein equals faster response. Once proximity is established, the queen's laying rate is limited by available warm comb and nurse bee population. Overfeeding doesn't accelerate expansion beyond biological maximums. The historical data from 1938 trials reported the following. Colonies with proximity-fed patties showed measurable brood in 2 frames by day 10, compared to less than 1 frame in control colonies fed at hive edges. By day 14, brood area covered 4 to 5 frames in proximity-fed colonies versus 2 to 3 frames in controls. This is not doubling overnight. It's a 10 to 14-day acceleration in brood expansion compared to typical late winter patterns. Spring populations in proximity-fed hives reached nectar flow strength 7 to 10 days earlier. This translated to surplus honey, increases of 15 to 25 pounds per hive in favorable flow years, not because the bees were better, but because population peaked at the correct moment. This method works under specific conditions. Condition 1. The colony must have adequate stored honey. Protein alone doesn't stimulate expansion. If energy reserves are depleted, bees need carbohydrates to metabolize protein. Condition 2. The hive must retain heat reasonably well. Drafty equipment or poorly insulated tops will negate the thermal advantage of proximity feeding. Condition 3. The queen must be young and productive. A failing queen won't respond to improved nurse bee efficiency. Condition 4. Varroa mite levels must be controlled. High mite loads suppress nurse bee health regardless of protein availability. This is not a substitute for fundamental colony health. It's a timing optimization for already functional hives. Modern beekeeping literature rarely mentions feed positioning as a variable. The emphasis is on feed composition, protein percentage, essential amino acids, attractiveness. But the 1930s trials occurred before the dominance of movable frame management systems designed for rapid manipulation. Beekeepers working with fixed comb or top bar systems intuitively understood cluster positioning because they couldn't rearrange frames at will. As frame manipulation became standard, the focus shifted to what goes into the hive, not where it's placed relative to the cluster. The biological principles haven't changed. Nurse bees still operate within limited radii. Queens still respond to pheromone feedback. Heat still rises. For beekeepers interested in other historically documented techniques that focus on biological timing rather than equipment changes, the Forbidden Beekeeping Manual compiles methods tested between 1920 and 1950, many of which were abandoned not because they failed but because they didn't fit industrial-scale operations. First link in the description. Proximity feeding doesn't change what protein does. It changes how efficiently nurse bees access it. By positioning pollen patties directly above the winter cluster center, nurse bees feed without leaving the thermal envelope. Hypopharyngeal glands develop sooner. Brood pheromone signaling intensifies faster. The queen expands, laying into available warm comb 10 to 14 days earlier than standard feeding methods produce. This isn't a miracle. It's alignment of feed placement with cluster behavior. If you're managing hives through late winter buildup, test this positioning adjustment on a few colonies and compare brood area at day 14. If this approach is useful, subscribe for more historically grounded methods that prioritize bee biology over product marketing. The bees haven't changed. The principles still apply.